This is the video introduction to Activity 3.6, Systems of Equations. In this activity, we'll use the substitution method and elimination method of solving systems of equations and view the solutions graphically. It's helpful to have a graphing calculator for this activity. A system of equations is two or more equations of the same basic type. A general rule of thumb for solving a system of equations is that you need the same number of equations as the number of unknown variables. That is, you can solve a system of two equations and two unknowns, a system of three equations and three unknowns, etc. We'll use two techniques. We use the substitution method and the elimination method. To apply the substitution method to solve a system of equations, use one equation to solve for one variable and substitute the resulting expression into another equation. This reduces the number of variables in the second equation, and you can continue to solve for the values of the variables that satisfy each equation. Let's look at a two equation and two unknowns substitution method example. We want to find the A and B that satisfy the two given equations. To use the substitution method, for example, we'll solve for A in the first equation and substitute that in the second equation. Let's look at that in detail. Our first step is to solve the first equation for A. You could always do this a different way. This is just one approach. We get A equals -3/2 B plus 3. Then we use the second equation and substitute this expression for A into that equation and solve for B. Our second equation is 4A plus 4B equals -7. And when we substitute the expression for A, -3/2 B plus 3 into that equation, we solve and find that B equals 19/2. Now we still need to know what A is, and we can use that value of B and the first equation to solve for the variable A. We could also use the second equation. When we plug 19/2 in for B, we find that A is -45/4. So now we have our solution. A is -45/4 and B is 19/2. We can check by putting those two values, one for A and one for B, into each equation. When we plug them into equation 1, we get 6, which checks. And when we plug them into equation 2, we get -7, which checks. To apply the elimination method, we multiply one or more equation by a carefully chosen constant, and then we add the resulting equations to eliminate a variable. Let's look at an example. Again, with two equations and two unknowns, and in fact, the same system. Our first step will be that we'll multiply the first equation by -2. There's lots of choices here. This is just one example. Now we'll add our new first equation, which is equivalent. Everything is multiplied by -2 to our second equation and add. When we do that, the A is eliminated. Notice here in the second equation we have 4A. In our first equation we have 2A. So when we multiply 2A by -2, we get -4A. And so that's our carefully chosen constant. So again, we get B equals 19/2. And again, we substitute in and we get A equals -45/4, which is good. It's the same system. It should have the same values. We've already checked that in our previous example. That's it for the prep video. You'll get lots of practice working with systems of equations in Activity 3.6.